So next in the unit, we're going to be solving rational equations. So if you look at your notes, the first question it says is, what should I do first? Since we're adding and subtracting equations that are fractions, we have to find a common denominator first. So go ahead and write find a common denominator. The next question on your note says what happens after finding a common denominator. So first, we're just going to look at a really simple example. And if you're looking at this example, 1/8 plus x over 8 equals 6 over 8, you probably can already tell that x should be 5. And that's just math that you're doing in your head as you're looking at the stuff on the top and you're thinking, well, 1 plus x has to equal 6. And so to make it equal 6, I know that x has to equal 5. And we're actually going to use that same method for when we solve our problems. So we're first going to find a common denominator, and then basically to solve the equation, you can ditch the denominators and just make an equation out of the numerators. So what we're going to do is an example, and you can go ahead and write 1 over 3a squared plus 5a plus 1 over 3a plus 5 equals 3a minus 18 over 3a squared plus 5a. So first thing, we're going to get our common denominator. So if I look at the first denominator, you should be able to see that there's a GCF of a. So if I take out the GCF of a, the leftovers would be 3a plus 5. The next denominator is just that plain old 3a plus 5, so it's kind of like what your parentheses were. And then the third denominator is actually the exact same as the first one. So if we look at what our common denominator is, we need to have an a and we need to have the parentheses of 3a plus 5. So that means that of the three fractions, the only fraction that needs to be fixed is the one in the middle. So I can go ahead, I'm going to leave the first one. The one in the middle, I have to multiply by a on the top and a on the bottom so that it has the common denominator. And then the one on the end can stay the same. And then once I have the equation written so all the denominators are the same, we're going to go ahead and ditch the denominators. So we'll get rid of those. And now the equation that I'm solving is just 1 plus a equals 3a minus 18. So just like you've always solved equations in the past, we want the variable to be on one side. So I'll go ahead and subtract a on each side. 1 equals 2a minus 18. And now I'm going to start moving numbers away from the a. So I'll go ahead and add 18 to both sides. 19 equals 2a, and then I'll divide by 2. And so the solution would be a equals 19 over 2. So just like we've been doing with equations in the past, we always want to check our answer. And specifically in these problems, we want to check and make sure that our answer is not extraneous. And extraneous answers would come in when you make the denominator of the fraction equals 0. So we're going to go back up to the original problem, that's the green part, and we're going to type that into our calculators and just check the intersection and make sure that 19 halves was actually a good answer. So here's a picture of what I typed in on my calculator screen. You can see that the denominators that I plugged in for those fractions, I just made sure that they were in parentheses. And then you'll notice with the right side of the equation, the 3x minus 18, that was multiple things on the top of the fraction, so I put that in parentheses as well. All right, so I went ahead and looked at the graph. I know that 19 halves is actually the decimal 9.5, so I went ahead and did second trace. I looked at the intersect function, and then I scrolled right until I got close to 9.5, which is over here. And you can't really see it, but the graph did find that it intersects at 9.5. So that means I did get the answer right, and it was not an extraneous solution. So on your notes, the next question there says, what do I do after I find the solution? And just like we've been doing lately, go ahead and write check to see if any solutions are extraneous. And this would be, by graphing, you're going to do second trace, option number 5.